Now, I say copy.update. What does model.update do? It kind of does whatever happens every single frame, right? So you see that update really is moving forward in time. So every time you call model.update, and notice I'm not updating the real model, I'm updating the copy of the model. But every time you call update, you're sort of moving on down one of these paths. You're saying, imagine that time went forward a little. And then when we call update again, we're saying, imagine that time went forward a little bit more. And we're kind of looking ahead into the future every time we call update. And then I say recurse, by which I mean, and for now let's ignore this logic, I'll explain it in a minute, but pretend it always goes down this path. I'm then going to say evaluate if I run and jump, and evaluate if I run and shoot. What I'm actually doing here is I'm saying, okay, now that I've gone forward a little bit, try each of the new 3 possibilities. And then each of those is going to try 3 new ones. And each of those is going to try 3 new ones. And each of those is going to try 3 new ones. And basically, this one function, even though it's only that big, it's going to systematically run down every single branch of every single part of the tree until it's thoroughly explored the entire future, all the way up to a depth of D, where D is whatever number I tell it. That's how deep it's going to go. Okay, so what is D? Yeah, it's how deep the tree is going to look. It's going to recurse that many deep. But don't forget, the cost is exponentially greater for every layer of D. Yes, in fact, that is a major important AI technique. And right here, I have sort of a quick, dirty hack that sort of does that. It doesn't do that as thoroughly as could be done. And if you want to do it more thoroughly, you'll be able to make a more intelligent AI. More specifically, you'll be able to make one that looks deeper into the future because it doesn't have to try as many paths with the same amount of computation. Okay, I guess I'll just talk about that right now. See how I say here, if depth mod k is not equal to 0, then just evaluate running. Otherwise, evaluate all these other things. Let me explain what I'm saying here. Okay. Let's back up a little bit. Do you see how if I systematically try everything, that tree just grows at a crazy fast rate? Exponential rate even. Well, what if instead I thought to myself, how often when playing a game do I just mash on the fire key? As in, fire, 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 fire. There's kind of no need, right? Of course, half of you do it anyway because you just hold down the key and you didn't check whether the key was already held down. You don't really need to jump repeatedly, right? So it makes sense to me that most of the time you're just running, and every once in a while you need to jump or fire. So imagine this is the state. That is a good question, and in fact, we might not be able to fully support that. One of the things you might need to do is mess with your physics engine to help the AI look a little smarter, and that's going to be okay. So if you want to turn that off for this assignment such that just tapping on jump makes it jump to its full height, I'm good with that. If you want to actually muck with the AI until it can manage that whole thing intelligently, that would be totally awesome, and I hope you will, but I'm not expecting that. So imagine here's the present, and I just do, let's just say run, and then run, and then run. And then maybe every 3 times I'm going to say, let's try fireballs and jump and run. And then down here I'm going to say, well, let's run and then run and then run and run and then run and then run and run and then run and then run. And then down here I'll say, okay, let's try fireballs and jump and run, and fireballs and jump and run, and fireballs and jump and run. And then we'll just run and run and run and run and run and run and run. And repeat that 3 times. Do you see what's happening is now I can look much, much farther into the future well, k times farther into the future, because I have just set k to be 3. By the way, these letters are not some kind of thing that everyone in AI agrees on. D and K are just letters I pulled out of nowhere because I needed them and I couldn't think of a good variable name. If you think of a great variable name, please send it to me and I'll update my instructions. So K is specifying how often we're going to try jumping and firing, and D is going to be how deep we look. And now let's see what that does to the math. Suppose I want to look 20 time steps into the future, but I'm only branching every 3 times. Then let's say I'm branching every 4 times, just so we don't get our numbers mixed up. We'll say K is 4. Because there's 3 actions, K is 4, my depth is 20. Now I'm only looking at 243 futures. Can a computer reasonably do 243 futures? Basically, it's making 243 deep copies of your model, which is by far the most expensive operation that it's going to do. But heck yeah, computers are fast. You can make 243 copies, which means we can look 20 frames into the future. Is that enough frames that it can jump from the top of one tube to the top of the next tube? Is that enough frames that it can see a Goomba out there and shoot it without dying? Maybe. If not, make K bigger. And if you make K bigger, then you can make D bigger. And if you make D too big and you make K too small, what's going to happen? Your program's going to be slow. If you make K too big and D too small, what's going to happen? Mario's not going to try very many things. He's going to only imagine in his head, well, I could run. And then he's going to say, well, that was my best choice. I'll just try it. And he'll run and he'll do something stupid. So you do want some branching, right? Because you want Mario to try a lot of different stuff. 243 is a pretty good amount. Maybe 1,000 is good. However much you can cram into a reasonable amount of time is a good amount. If it's too slow, you're branching too much or too deeply. So you either need to make it less deep or less frequent. And as long as you get a decent amount of branching, then Mario will explore a number of possibilities. He'll try them all. He'll pick the one he likes the best, and he'll behave intelligently. Am I hearing correctly? The question is, would it help if we added some custom logic, as in we used our own intelligence to say, under these conditions, we should try these different options? Is that what you're asking? Oh, you're saying, instead of having just these 3 choices, what if we branch it out into 5 choices? Yes. I picked 3 as my guidelines because I did. I don't think that's any kind of optimal or intelligent thing to do. If you have 5 actions, what you've effectively done is you've turned your branching factor into 5. So you're going to branch a little faster. So that's going to have an effect. But now Mario is trying more futures and he's experimenting with more things. So absolutely he can do more intelligent futures. Let's walk through a really simple example. Let's suppose green squares represent our pipes. I'll make them look pipey by putting a top on them. And this red square represents Mario. I'll make it look like Mario by adding a mustache. Okay. Looks like a bird. He needs eyes. Now it clearly looks like Mario. Okay. Mario's coming along. Imagine that we made the pipe so tall that Mario couldn't. Imagine that this pipe is so tall that Mario can't get over it. Meaning, if Mario comes along, jumps over here, falls down here, runs there, and jumps, he'll go boing, 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 boing. He can't get over it. That would be bad because he can't progress. But if he were intelligent, he'd jump on here, and then he'd run and time it exactly right, jump, just so that he's going to land right there. And then he'll keep on running. If Mario successfully navigates that challenge, he has demonstrated artificial intelligence, right? Now, what are we going to need in order to achieve that? Well, Mario's up here, and there's two actions he could do. One of them is jump right now, and if he jumps right now, he's going to go, bing, oh no, death. One of them is continue running forward, and then jump, and then one of them is continue running forward and run forward again and fall down here and then get stuck. How does Mario know the correct answer is run forward now and then jump? Yeah, but all of that is implicit. Because I'm branching, because I'm trying all possible actions in all possible futures, one of those is first Mario runs, then Mario jumps. And because that one, we'll say it happens to be this path, where first Mario runs and then Mario jumps. I think up was fireballs, huh? I said down was run, and then middle was jump. Because this is the one glorious path that leads to a bright future, what action should Mario do right now? Run forward. Do you see that this time, the time step immediately in front of you is now? And then this is one time into the future, and this is two times into the future? Okay, so Mario knows that right now he should do the action of just run forward, and in the future he'll jump, because this is the one path that leads to happiness in the long run. So the way this whole thing works is it's going to do this recursion where it tries all these different things, and then when it finally gets to a depth of d, we're going to basically count the score. Now, I picked an arbitrary score here. I said Mario posts, so the farther, by which I mean the scroll position, the how far Mario is to the right. Basically, getting to the right is good. Mario wants to keep on running forward. And then I'm going to say, hey, plus a bonus of 20 points if you kill the Goomba, because we hate Goombas, those pesky, wascally, squashy things. But I don't want you to waste fireballs, so I'm going to penalize Mario for every fireball that he throws. So how would you expect Mario to behave? Yeah, he'll basically run along, and if there's a Goomba, he'll throw one fireball. And that fireball will bounce and kill the Goomba, and he'll be dead on, and he'll never throw any other fireballs except the one that slaughters the Goomba. And that's how we'll recognize well-written code, is it will play conservatively. It won't waste fireballs, but it'll kill every last possible Goomba, because it's well worth the 20 points in the future of taking a hit right now. And let's also not waste jumps. So obviously you could write a program where Mario just goes boing, 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 and he'll get over all the tubes, right? Well, maybe. Not if you have one of these hard tubes that he can't jump over. But what's cool is if Mario only jumps when he needs to and still manages to clear all the tubes. Imagine a bunch of stair steps of tubes. Wouldn't it be kind of slick if you had a case where the tubes look kind of like this? Only an intelligent player could get over that, right? Because any dumb AI would hop on one of them and not time it correctly and would fall down in the pit. But an intelligent AI, in theory, should be able to go run, 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 jump, run, run, jump, jump immediately, run, run to the very edge, and then jump, and then barely make it, and then run, 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 and then jump. Of course, it has to be possible, right? If your AI can't find a future that leads to success, it's going to die. That's not the AI's fault. It's the fact that your game's impossible. So you're going to have to make your game. You're going to play some games with the game. You're going to be messing with the tubes to try to help the AI, and then you're going to mess with the AI to make it succeed until you make a thing that can actually play intelligently. Then you'll turn it in and get all the credit. Yeah. Basically, for this assignment, let's keep it minimal because I don't want to dump on my class. But yeah, you certainly could make it have actions for going to the left. You could do all kinds of, I hope you will mess with my heuristic. So this is called a heuristic. A heuristic is where you basically pull a score out of your armpit. And there's no reason why this is the true thing for Mario to do, but it's kind of what I say represents a good future. Mario gets really far to the right, and is rewarded for dead Goombas and penalized for fireballs and jumps. Sounds good, something to do. If you want to mess with the heuristic, that's cool with me, but make sure that it's kind of like this one, or else the grader might not recognize that he's doing what he expects. If you want to mess with your game, by all means, please make different maps, change the tube heights, fiddle with it until, until Mario can handle it. If you want to mess with the AI, like have more actions. In fact, if you have an action that isn't move forward but is just stand still, that might help Mario not overjump. For example, you don't want to overshoot this one, right? If you had an action for just stand still, he might jump over and then drop straight down and land right on the tube. So maybe that's an important action to also be able to stand still. And you are free to mess with all the variables. Your assignment is just make a map that's big enough, maybe 3 pages worth. It has a lot of tubes, some scrolling going on, some Goombas to shoot. You better have more than one Goomba. Have a bunch of Goombas and a bunch of tubes, and let Mario run along. So the grader will basically do this. He'll run your program, he'll look back, step back and look at it. And if it looks like Mario's smart, and Mario is smart if he conserves his fireballs and his jumps, but he manages to navigate difficult challenges, then you nailed it.